So now we're going to look at how to apply Le Chatelier's principle to chemical reactions. So this is my equilibrium sign. I couldn't find the true one. It really should look like this. It should be a double arrow. That's what you'll see, or sometimes you'll see half arrows like this, which is totally fine, but you'll usually see things like this or this. I couldn't find it in the Word file when I made this, so I used this. But anyway, this is the equilibrium sign. This is the center of the chemical reaction. And in order to use Le Chatelier's principle, we assume, so here's my little seesaw, we assume that the seesaw is fully balanced with everything the way it is, meaning that in the balanced equation, this part, the way it is right now, means we have a perfectly balanced, even seesaw. And so what we're going to do is we're going to look at how these different stresses affect the chemical reaction, okay, and which way it shifts. Now, the beauty of this is once you know which way it shifts, the problem's over. So let me give you an example. So if I were to add N2 to this, so if here's my balanced equation and N2 is on the right, if I add more N2, the seesaw is going to go like this. So the left side goes up, the right side gets heavier and goes down. That means my shift is to the left. We always shift to the side that goes up. Now, once I know that, it's very simple. The side that went up physically went up like on the seesaw, but in chemical equations, it also went up in terms of concentration. Basically, if you're on the side that goes up of the seesaw, your concentrations also go up. And if you're on the side that goes down, your concentrations also go down. So therefore, these things went down. Now, if you notice, I have a double dash here or a triple dash here. That's basically because I am manipulating the equation by adding more N2. So we can't count that as going down. What's happening is the rest of the reaction does this in order to, as a reaction to me adding more N2. So that's what we're really doing. What really happens, it's really collision theory. Basically, by increasing the amount of N2, I'm going to increase the likelihood that N2 and H2 collide with the right amount of heat, okay? And therefore, they're going to make the reverse reaction happen more often, which means I will make more NH3. Now that will continue to happen until I have enough NH3 to rebalance the equation. So it's really collision theory that's driving these, but if that was too complicated, you can just seesaw method your way through it. It's pretty simple. So if I add NH3 to this equation, then the right side of the seesaw goes up and the left side goes down because it gets heavier. So my shift is to the right, which means everything on the right increases and everything on the left would decrease. But since there's only one thing on the left and that's what I was manipulating, it gets the dash there. Remove heat. So even though heat has no weight, in an equilibrium formula, we pretend like it's part of the seesaw and that it does have weight. So if heat was, let's say I had, 3 little kids on this side and they were perfectly equal to, one really big adult here. Well, if one of the little kids jumps off, then in this case heat, it's going to make this side lighter and this side's going to go up. So my shift is going to be to the right. So those things are going to go up. Heat is what I manipulated, so I can't really say that would increase, but I'm adding more, so we don't count that one. And this is on the side that goes down, so therefore it's going to decrease. And again, collision theory. By removing heat, then that makes the collision of these 3 things less likely because now there's one of the components is not there, so then these 2 things, NH3 colliding with itself and breaking itself up, becomes the more likely reaction, making more of the things on the right, hence the shift to the right. That's the last time I'm going to use collision theory to explain this, so we'll go a little faster. Remove N2. So N2 is on the right, so the right side, the shift is going to be to the right because the right side will get lighter and go up, so the things on the right increase in concentration and the ones on the left decrease. Remove NH3. So if NH3 jumps off this seesaw, the left side is going to go up, so we're going to shift left, which means the right side is going to go down and the concentrations will decrease. Add heat makes the right heavier, so therefore the right goes down and the left goes up, so my shift is going to be that way. These will go down. This will increase. Add H2. So H2 is on the right, so if I add it, it's going to be heavier. The left side goes up. Right side decreases, left side goes up. Now pressure. Pressure is the one that we're going to have to pay attention to. So with pressure, you have to memorize what pressure does. When you increase the pressure, you shift to the side with less moles of gas. So when we talk about moles of gas, we are only concerned with these numbers here. So, and obviously they have to be gases. If they're not gases, then we don't care about them at all. So we have, there's an unwritten one here. We have 4 moles of gas on the right and 2 moles of gas on the left. So if I increase the pressure, I'm going to shift to the side with less moles of gas, which means I'm going to shift that way. Which also means decreasing the pressure does the opposite, so I can just do that. And if we know what shift means, it means I make more of the side that goes up. So whichever side I shift to, they are going to increase their concentrations, and then the other sides do the opposite things, and they are going to decrease their concentrations. What does this really do? Basically, when you increase the pressure, you're squeezing the container together, making it smaller. So what's really happening is, if I have all this stuff in a container and I shrink the size of the container, what it really is saying is that since there's more of these gases, they are more likely to collide than these 2 gases. These 4 things are more likely to collide than these 2 things. And so that's why you shift to the side with less gas. In other words, these collisions will happen more, so you will make more of the things on the left, hence the shift to the left. I'm not going to do more than that with you, but I will do another pressure one, because I want to make sure everybody understands pressure completely. So with pressure, let's look at that. Again, we only care about gases. So if these were liquids or solids or aqueous, then we would totally ignore them. And we want moles of gas. So we have 1, 1, and 2. So I have an equal amount of moles of gas on each side. So if you increase the pressure, you shift to the side with less gas. Since neither side has less gas, there's no change in pressure. Pressure would have no effect on this equilibrium because pressure only affects gases. Let's do one more with pressure to make sure everybody fully understands this. This one at the bottom is pretty good because a lot of people make mistakes on this. So again, pressure only affects gases, which means there's 1 mole of gas on the right. This liquid means I don't count it, and this AQ means dissolved in water, I don't count it. So if I increase the pressure, I shift to the side with less moles of gas. So think about this. I have 1 mole of gas on the right, and I actually have 0 moles of gas on the left. So the shift is going to be to the left because 0 is obviously less than 1, which means the left side will increase their concentration and the right side will decrease. The reverse does the opposite. And it looks like that. And that should be it. I will send out an answer key with all of the answers on this. There are 2 worksheets for this. I just went over the first. The second worksheet has all the same problems. It's just more practice. This does take a little while to get the hang of it, but once you get the hang of it, it will go very quickly. So I will send out answer keys for these later on so that you can try them and check your work, and then there will be a castle learning on this topic. I recommend you do that the very last because this can be a complicated topic.